Okay, the first thing I'm going to do, for the moment we're not really interested in the particles, so you can see they actually do slow down interactivity a little bit. So I'm going to bring up the particle view and I'm just going to turn off this source, which as you can see turns off all the particles which are associated with it. So there we go, we've turned off our particles for now. The next thing I'm going to do is, actually let's just unfreeze everything. And I'm going to texture the plinths and the teapot and the ground, the ball and the rope with a default material, so we have a very basic scene that we can light with. If I do a render now, you'll see that we end up with default render basically using just some lights which are projecting from the camera, from a perspective camera. And it's not particularly interesting in terms of rendering. So let's go to a front view here, and let's create a spotlight, a target spot. I'll put that slightly off center here, so it's shining down onto the teapot. Let's move the source of the light over here a little bit, and in perspective view, let's move it again a little bit off center, otherwise it's going to be the rope will cause some really nasty shadows as it passes through. So I'll just put that here. Okay, that's cool. And we'll zoom in on the teapot and just do a quick render of that again. Okay, you can see it's very, very bright at the moment. So the first thing I'm going to do is actually just tweak the brightness values of that light. We'll just put that down to 1, only a 1. In this case, I'm going to go for a kind of cool blue light. So I'll just reduce the saturation on that a little bit, so it's only slightly blue. There we go. And I'm going to turn on shadows and change that to shadow maps. There we go. And I'm going to go to the shadow map parameters. Let's just make this into 2 columns here. I'm going to go to shadow map parameters, and let's just make the shadow map a little bit more detailed, and do a test render of that again. Okay, now you can see we've made it a lot darker, and you can see now that the teapot has got shadows being cast, and you can see that the plinth is casting shadows on itself on the floor and so forth. So it's starting to look a little bit more realistic, and it's also looking quite a bit more moody. Let's make a material for the floor. I'm going to go for a kind of Aztec theme here, so I'm going to create a material here called Aztec glyphs. There we go. And I'm going to create a bump map for that using a bitmap, and I'll just go to my maps here and my tutorial maps and pick up glyph. Just open that. There we go. You can actually view this image by pressing this button here, and you can see this is a sort of stylized group of 9 glyphs which I actually scanned in from some real Aztec archaeological sites, from a book of course, not actually from going to Mexico and scanning them there. I'm gonna, well actually let's do a quick render of that, see what we get out of it. It would help if I actually applied the material. I can apply the material to the selected object using this button. There we go. I'll do a render of that. Okay, you can see at the moment you're only seeing really one of the glyphs, and it's very, very large, so I'm going to increase the tiling on that bitmap by 2. So it tiles it twice, and it's looking a little bit better, but probably you could actually do with some, maybe a little bit more. There we go. So now we're getting some quite interesting detail on the floor. I'll just crank up the strength of the bump map there. Do a test render again. That's looking okay now, I think. Maybe a little bit more. Okay, yeah, that's looking quite cool. At the moment it's just using a diffuse grey for the colour, so I'm going to put something a little bit more interesting there. Maybe a little bit of noise. And I'm going to use 2 maps actually. I'll make them both a sort of beigey sandstone colour. There we go, that's quite cool. We'll just copy this colour to here, and maybe make it a little bit darker for some variety. I'll make it a fractal, and just bring the colours a little bit closer together here. if I click on that button there, you can see this a little bit more clearly what I'm doing. There we go. So that's quite nice. Make that a little bit smaller. This is a fractal texture, actually, the noise. There we go. So that looks a little bit more interesting in terms of looking like stone. I'll mix this together with a smaller version of itself. So I'll go to the mix map. I'll keep this map as part of the mix map. So there you go. It's actually kept the noise map in there. And I can actually drag this here and make a copy of it. And now this one will make quite a bit smaller. So it produces some fine detail. And we'll just mix that in with the other one. So there we go. We have something a little bit more interesting now. Okay, do a quick test render of that. And there you go. You can see the stone's a lot lighter. And because the actual light from above is predominantly blue, you can't really see that much of the beige color that I put into it. So, but you can see there is a little bit of variation in the brightness. So let's actually create a little bit more variation there. We'll effectively crank up the contrast a little bit. So there we go. And if I do a render again, yeah, you can see now there's a little bit more detail there. So that's looking quite a bit more interesting now. The next thing I'm going to do is do the same thing for, well, actually, the next thing I'm going to do is add a light source to our flaming ball here, to make that look, you know, it'll look a bit strange if the ball's on fire and it's got flame coming off it, and it swings through the scene, but it doesn't actually cast any light. So let's create a nice light source for that. In this case, I'm going to use an Omnilight. There we go. I'll rename this to Fireball. There we go. And let's do a bit of naming here actually on quite a few objects. It's very useful actually. It's a very good discipline to get into, to actually name your objects when you're working on a scene, because there's nothing worse than getting a scene from somebody else, even if they've been in a rush. And they've not actually bothered to rename any of their objects, and you basically just get a bunch of objects called, box 1, box 2, box 3, which is pretty irritating, and it doesn't really give you any information about what you're actually really looking at. So it's actually quite vital, really, to actually do that. Here's a good example. Cylinder really should be called rope, shouldn't it? Geosphere, let's call it fiery ball. There we go. And another thing that you can actually do is to, if you look in the lister here, when we turn on all, you can see you've got a bunch of objects and they're in no real order. And without knowing more about Max or the scene, you may not really know exactly what each type of object is. So it can also be a bit of an idea to give things a prefix as well. So in this case, we've got a teapot here. Let's call this, this is a prop, so we'll give it a prefix of PRP. There we go. These plinths are also props, so we'll call those PRPs as well. Let's do the same thing for this shattered plinth here. Same here. Okay, the ground plane is part of the set, so we'll call that set. And you can see I'm using a 3-letter prefix, which basically is enough usually to give you an idea of what the object is, whilst not making the actual prefix into something a little bit too long-winded. So let's just rename these. These are also props. Plinth detail. We'll give that a number, and we'll copy that and we'll put that onto the other plinth details. Just increase the number each time. There we go. Oops. It's also quite useful. Quite a nice way of working is to actually work on a scene like this. And get to a certain point and then say, okay, I'm going to hand this on to somebody else now, and use some renaming tools to actually batch rename a large number of objects. You can see what the result is now of using this prefix. You can see that all the props are listed together in the list here. You can see the rope actually is a prop as well, so let's just select that. and we'll call that a prop. Okay, and we'll call the fiery ball a prop as well. And actually thinking about it, considering that these objects aren't animated in any way, we'll actually call them part of the set instead. So let's reassign these to set. This to set as well. There we go. And the same for this fellow. Okay. Okay, that's cool. There we go. So now if we look at the list, you can see it's a lot more ordered. It actually gives you a much better idea of exactly what each object is in the scene. I'm just going to call this a light, because you could actually take out the Omni and then you may not actually have much of an idea that it's actually a light. And I'm going to do the same thing for the spot here. Get rid of the number 1 and we'll call it light. There we go. So you can see your Omni, Fireball, light and your spotlight are now actually listed together in the scene. So you know, you can get the idea of how useful it is to actually follow that kind of procedure. Okay, so we've got our Omni light here, and I'm just going to position this in the center of the sphere here. Let's zoom in a little bit. Okay, there we go. I think that's pretty much good enough. And then I'm just going to link it to the sphere. I need to make it a nice sort of fiery color, so I'll just do that. And I'm actually going to give it a range so it doesn't light up infinitely in the same way as the spotlight actually is. Basically, if I had the spotlight and I moved it, you know, in real terms a mile away, it would still light up everything in this, you know, inside its cone of effect. And we don't really want that to happen with the fireball. We want the light to sort of fade out. So I'm going to turn on fire attenuation here. And it's got two values. One is the inner attenuation where it's at 100% strength, and one is the outer value. So basically when the light gets to this edge here, it'll have 0 effect. So let's extend that out a little bit more so it lights up a bit more of the scene. Okay, that's pretty cool. And I'm just going to make this light so it fades off in a inverse manner. So basically now that I'm using inverse, we can crank up the intensity of the light quite a bit, as the light will fall off much more quickly. Let's bring the light in closer to the teapot and do a quick render of that and see what we have. Okay, you can see it's very bright now, so let's maybe knock down the brightness a little bit. Do another test render. I think that's a little bit better. Now, one of the problems at the moment is that the Omni light doesn't actually have a shadow, so let's turn on shadow casting, and we'll leave it on shadows, shadow map. Let's do a render of that. Okay, that's looking quite cool. Now, something that can happen is the Omni light is actually inside an object, and if that object had any sort of thickness, any faces which were facing the Omni light, the light wouldn't be able to get out of the sphere, because basically it's casting shadows and it's inside the sphere, so therefore, you know, the light wouldn't be able to escape. So let's right click on this sphere here, the flaming ball, and we'll turn off cast shadows on it. So if it did have any thickness to it, it wouldn't actually stop the light from the Omni light from getting out of it. If we do a render now, we've got shadow maps turned on, and you can see we've got a nice shadow coming off here. One of the things though about shadow maps is that there's no provision in them in 3D Studio Max for producing anything other than a point light. And the problem with a point light is that if it's infinitely small in size, and therefore the shadows it casts are always very sharp edged. Whereas in this case we're actually rendering quite a large object really, which is luminous and giving off light. So we really want to use area shadows for this. So in this case we've got area shadows here, and we can go down to the area shadow dialog. There we go, and you've got various parameters there for quality and so forth. Let's do a test render with that, and we'll see what the differences are in the shadows. Mostly you'll probably see them on the ground plane here. Yeah, you can see that as the shadow gets away from the base of the plinth now, it becomes much softer. It's a much sort of nicer quality shadow. Okay, let's set up a view for our shot. So we're going to go somewhere around here, I think. And let's just zoom in a little bit. But I think that's quite nice. So we get a nice view of the ball flying in and smacking the teapot, and the teapot bounces towards us. I think that's a reasonable sort of composition. So if I move the perspective view now, of course, I'll actually lose that composition. So effectively, I'm going to set that in stone, so to speak, by creating a camera, create a target camera here. And whilst I've got it selected and I'm in perspective view, I'm going to do Control C, and that will actually make that camera take up the position and the perspective of the current perspective view that you're using. So now, if I press P to go back, actually I'm still in perspective view, so I can move around, and there's the camera, which I just used, created by actually pressing, creating a camera and pressing Control C to actually snap it to the view that I had. If I press C now, it'll take me to that camera view, and P will take me back to perspective view. So there we go, that's quite cool. If there was more than one camera, you'd have a list and you could choose which camera you actually wanted to go to when you press C. So let's go back to our camera view and do a quick render from there. Okay, that's quite cool. You can see that because the fireball is up in the air, it's actually not, the light isn't actually reaching down all the way to the plinth, which is probably not really that realistic. So we'll just increase this range here, this maximum range, a little bit. Let's try another render. Okay, that's a little bit better. We're getting a bit of lighting coming up here on the edge of the ground plane. Let's do a test render as it comes in and hits the teapot. There we go, do a test render there. You can see that's pretty cool. We've actually got a nice big shadow here from the plinth, and you can see it's nice and soft. So that's looking a lot better, I think. Okay, so at the moment both our plinth and our teapot are not textured, neither is our fireball or our rope, so let's do that. Let's actually texture the fireball. I'm going to create a texture here called fireball. There we go, and I'm going to make it self-luminous using color. And let's create a self-illumination map, which I'm going to use a noise map to do. Let's use some colors which are a bit more flame-like rather than black and white. Okay, let's use that, and okay, that's quite nice. And we'll just apply that material to the fireball, do a quick render. Okay, you can see that the actual noise texture is probably a little bit large, so we'll make that a bit smaller, and we'll change it to turbulence and do a little bit of that with it. Okay, so that's quite nice interesting texture. Now I'd like the texture to boil, to change as it flies through the air, to give the impression that the surface is alive and it's on fire. So I'm actually going to animate the phase here. If we put it back to a large size, you can actually see the surface of this texture here. And if I change phase, you can see that the texture actually swims through the sphere here. And I want that same kind of effect, but I want it animated when I actually play back the animation. So I'm going to put some keyframes on this phase value here. So let's put it back to 0 here. Just turn on auto key, go to the end of our timeline, and input a final phase value. So let's put in 7. And now if I turn on auto key and scrub, you can see that the actual texture here changes over time, which is quite a nice effect. Quite interesting. Stops it just looking static. It'd look a bit strange if this thing's supposed to be on fire and there's no real sort of change to the surface. So that's quite cool. We've very quickly produced a nice sort of animated texture there. Okay, the next thing is to actually texture the plinths. So let's select the various elements that go on the plinths. And I'm actually going to select those objects there. And you can see already I benefited there from prefixing all the set objects with set. I just selected everything with set and just deselected the ground plane. So that's pretty cool. Let's create a texture called plinth. There we go, and we'll just assign this texture to all the objects. Now, something I'm going to do here is I was actually just put this back to I just dragged it from there. Something I was quite happy with there was the actual texture that I used on this material. So I'm going to reuse this diffuse material on this plinth as well. So we use the same kind of sandstone on the surface. So I'm going to change this name here to sandstone diffuse. There we go. And I'm going to just drag it over here into this slot here and keep it as an instance, so it's exactly the same. And now this same map is instanced into this window. And what I'm going to do here is go to the maps window. Actually, let's just reorganize this because I've inadvertently reorganized this rollout. So we'll grab maps and we'll put that underneath super sampling, and we'll get shader basic parameters and we'll put that back at the top. There we go. So the rollout's back in the normal order that we'd be in. Go into maps and drag this into here. That was just another example of how you can actually customize Max's interface. You can change the order of rollouts to whichever order that you prefer. So yeah, I've just dragged this in here, and I'm going to say, yeah, make that an instance. So you know, any changes I make to this version of the texture will get propagated to this version of the texture. So that's pretty cool. But I'm going to create a unique bump map for this, using again noise. Let's make the difference again between these two values a little bit smaller. Let's make this a lot smaller here, so we have much smaller noise. I'm going to make it fractal, and again I'm going to turn it into a mix. So let's choose a mix. Yes, I'll keep this current map. We'll copy that map. We'll have it blend those two together using the mix value, and I'll just change the size of the second map. So now we have some variation in our noise, and you can see it looks reasonably stony there. Let's just do a quick test render of that to see what that looks like. So there we go, we've got a nice sort of stone plinth now with a nice texture on it there. Okay, let's make the teapot look a little bit more special. Now it's, you know, this is meant to be some kind of holy relic or something, so let's make it look quite shiny. We'll just put a new texture on here, and I'll call this Holy Teapot. Okay, and let's go down to maps. I'm going to give it a reflection. I'm going to choose a bitmap. In this case I'm going to use this texture here, which is a HDRI image which I've actually done of my own living room, which is going to reflect into the teapot. So we're not going for a very realistic effect here, but just something interesting to reflect on the surface of the teapot. Just accept those values, and we're going to use it as an environment, a spherical environment, so it'll wrap around the teapot and it'll look quite interesting. Actually, let's go down here and increase the intensity of the reflection a little bit more. Okay, there we go. You can see here there's the reflection that we're going to see in the teapot. So we'll just knock that down a little bit, and we'll make it the teapot a little bit darker and a little more maybe bronzy looking. And we'll give it quite a sharp highlight so it looks maybe metallic. There we go. So I'll just pop that on there and do a quick test render of that. And there you go, you can see it's got something a bit more of an interesting surface on it now. Maybe that reflection's not quite in the right place, so I'll just rotate the reflection a little bit here. Let's try that. Okay, and let's just put it around a little bit further. There we go, try that. Okay. Quite like that now. So let's have a look what the fireball's like just as it's about to strike the teapot. Comes in and smacks it, and let's do a quick render of that there. You can see the teapot's looking pretty cool, nice and reflective, metallic looking, with stones looking quite stony. Maybe the stone's looking a little bit too large, the texture there. So let's just go into the bump and make those both a little bit smaller. Just knock that down, and do the same thing for the other bump. There we go. And maybe this is slightly higher status, so we'll go for a slightly better finish here on the stone. So there we go. We've got our plinth, and we've got our fiery ball, and we've got our teapot, and it's been struck by the fiery ball, and it's flying through the air. one thing you'll notice here is, you know, this teapot really should probably be blurring at this point because it's been hit and it's flying through the air quite quickly. So let's go to there and look at the properties, and we'll turn on image motion blur in this case, which is a nice quick method for doing motion blur using a 2D motion blur method. We'll go to the render dialog, and we'll make sure that image motion blur is turned on, and then just do a quick render test of that just to see how that comes out. Okay, and there we go, we can see the teapot is motion blurred now. We'll do the same thing for the fiery ball. Turn on the properties of that. There we go. I'll go for image on that. And we'll do the same thing for the rope. Now, the rope actually isn't... no, actually it is rotating, so it will actually blur. One of the problems with using modifiers to produce animation, for instance, is that if the object didn't transform, i.e. the rope didn't actually move through space, Max would interpret that as not actually moving. It would just say, oh, it's deforming, and therefore it doesn't have any motion blur. That's one of the problems with image motion blur. It doesn't take into account deforming objects, deforming surfaces, which, if this rope only had a bend animated on it, that's all it would be. It would just be a deforming of the surface instead of the rope actually moving. Though luckily in this case I've actually rotated the rope, so that actually should motion blur. So let's just do a quick test render of that, and these two objects should now motion blur. Okay, so there we go. We've got the fiery ball and it's motion blurring, and we can see the teapot's motion blurring. So we've got a quite nice look to that there. Okay, so now that we've got quite a reasonable looking render, I think we should move on to maybe working on the particles. So bring up particle view again. We'll go back to frame 0. Let's turn on the particles. Now at the moment the particles don't actually have any real geometry. There's no real shape to them, and it's only because of the display operator that you're seeing them as lines in the viewport. So in this case I'm going to use a shape facing operator which will make rectangles that actually face towards a camera. So we'll just put that here after force. We need to add a camera to that now, so we'll go here and we'll say use this camera. We'll just limit this to cameras here. There we go, use this camera, and now all the facing shapes will actually point towards the camera. Let's actually get some particles going here, and I actually want to see these in the viewport now, so let's change the display from lines to geometry, and that will actually show the geometry of the particles themselves. So if we let this play through, you can see you've got these little tiny rectangles. They're actually pretty tiny, so let's get the particle view back up and change the size of those. I'll base them on screen space, so they'll actually be based on the image size. The proportion at the moment, you can see if I move this down, is 1%. So we'll change that to 2%, so a little bit larger, and we'll change the variation in the size of them to 50%, so there's quite a bit of a variation in the size of our flame particles. So that should look a little bit more interesting. Now the next thing to do is actually to make a material for them. So you can see I've run out of material slots here, so I'm actually just going to drag this over here a little bit. There are actually a lot more slots in here than just 6. There's a full 24 as far as I remember. So we've got another 6 over here, so we'll just make use of those. So we'll call this flame, and this is going to be a self-luminous material, so we'll just turn this into 100% self-luminous. It's going to be an orangey kind of texture. There we go. And we're going to use a map to control the opacity of it. So we'll go in here and we'll choose a gradient ramp, and we'll make it into a radial gradient ramp, so it's now circular like this. And in this case white is opaque and black is transparent, so at the moment our gradient is actually backwards. So we'll just change this to white, we'll just change this to black. We'll copy this flag just by dragging this like this. That's just to make sure that it's completely transparent at the edge. I'll get rid of this flag because I don't really need it, and at the moment it's 100% opaque in the center, and I really don't want that, so we'll go for 50% opaque. So that's pretty cool. And the transparency method needs to be changed so that as the particles overlap each other, that this orangey color which I have here will add up and produce a nice sort of flame effect. So I'll just go for change that color there. and go to extended parameters and change it to additive. There we go. So to apply this material to the particles, I'm going to use a material static operator. We'll just put that after the shape facing. And all I need to do now is just drag, oops, actually you need to select the operator first. There we are, material static. Just drag that material onto there and say it's instance, so that now you can always update it by going to here. Okay, we have a cache operator going, so let's just close these both down and let it play, and we'll just cache our particles so that we can not really worry about them from now on, and we can just scrub back and forth and we'll have nice fast playback. Okay, almost there. There we go. We've got our nice cache particles, nice and fast there. And you can see, like I said, you can scrub back and forth very quickly now. That's pretty cool. Okay, let's move it forward a little bit and do a quick test render of that, see if that's looking okay. Okay, so there we go. We've got a kind of flame effect. It's a little bit cheesy. It's not really that much like flame, but it's a nice, quick and easy way to get a kind of flame effect going on there. Okay, and let's go to here. Now, an interesting thing is those particles are, they're in the scene, and they're actually shadow casting. So we really don't want that because, fire generally doesn't cast shadows. Well, obviously the light from a fire would cast shadows, but the flame itself doesn't actually cast shadows. So let's turn off the shadow casting on those to get something a little bit more realistic looking. And we do that in particle view. Each event in particle view has its own render properties. So we can go here and we can say these do not cast shadows, they do not receive shadows. You can also stop them from appearing in reflections, or you could turn them off so they're not visible to the camera but actually do appear in reflections and so forth. So you got a lot of flexibility there. So we'll just turn that back on. Okay, so those now don't actually cast any shadows anymore, which is quite a good thing. Just do another test render of that. You can see it actually renders quite a bit faster now. And you can see the difference. The actual flame here was blocking out the light getting to the plinth, which is obviously completely unrealistic. So there we go, that's looking a lot better. I'd say at the moment maybe the particles could probably do with being larger, and maybe over time they could also do with growing in size or shrinking in size, and possibly also fading out. And you could do that with a number of methods, which we won't actually go into in this particular tutorial. Okay, let's make a few more tweaks here, and then we'll go on to doing a final render of this. You can see at the moment here, you can see the base of the floor, which is not a good thing. So I'm just going to zoom the camera in a little bit here using this dolly tool. So it's actually not zooming, it's moving the camera itself, I should say. It's not really a zoom. And then we'll just pan the camera slightly up a bit so we see a little bit more here. Okay, that's better. Okay, that's pretty cool. Let's just do a quick render of that, see what that looks like. Okay, what else could we say here? Let's go back to the beginning. I think maybe at the moment the spotlight's illuminating maybe a little bit too small an area, and maybe the fall off is maybe a little bit too severe. So we'll just select that spotlight up here. Just change this just to lights, and I'll change the fall off a little bit so the light shines. There's a bit more of a fall off between the hot spot of the light and the edge of the light. So just make that a little bit bigger. Okay, there we go. Just do a quick render of that. Okay, that's pretty cool. We'll also make this light into an area light. I think that might be quite interesting to see what actually happens there. So we'll try that. Let's try area shadows on that. And go to area shadows. It's a rectangular light at the moment, and it's got this scale. So let's just try that, see what that's like. Okay, you can see you've got slightly softer shadows here now, which I think is probably preferable. Let's actually change this light here to, it's actually using a rectangular shadow, which actually isn't very realistic, is it? Because it's actually more of a sphere. Let's change that to sphere, and we'll just keep these values here. And let's do a quick test render of that down here maybe. Okay, that's pretty cool. And maybe this fiery ball really isn't looking particularly fiery at the moment, is it? It's looking a bit orangey, and also probably this light is actually producing too much light for this orangey ball. So we'll just knock down the intensity of this a little bit, and we'll just tweak the texture on this to make it maybe a little bit more extreme. So there we go, we'll put that up there some. We'll just increase the amount of white in the texture. There we go, let's do a quick render of that. It's looking pretty good. The intensity is better now, it's not whiting out so much, which is, you know, you can see a bit more detail in the highlight areas. It's looking a little bit better. There we go. At the moment I think the texture here is maybe a little bit too large, so we'll just tweak that and we'll make that a little bit smaller. Let's just put that down to, there we go, to 12. Okay, let's do a quick render of that. So there we go, it's looking a bit more interesting now. I'll just cancel that and make it a little bit smaller again. There we go, try that. Yeah, that's looking pretty cool now. Looks kind of weird, doesn't it? Which is pretty much what I was going for. Maybe that light's still a little bit too bright, so let's just knock that down just a little bit more. Try one more render. There we go. It's looking pretty cool. Now, one thing you can do, and it's probably best to actually show you this with the particles turned off, is to use a thing in Max called a light tracer. And the light tracer in Max basically allows you to use GI in your render. Now it's best to illustrate this. If I move, let's say, the ball back here, what I want to get is some reasonable lighting on the floor, but some interesting shadows here. So let's do a quick render at that point. See if we get something nice. Yeah, I think that looks pretty cool. What you're getting here is, you know, there's a large amount of light appearing to come off this flaming sphere, and it's causing a very large shadow underneath, you know, the edge of this plinth. But it's lighting up the ground plane, you know, quite a lot, and that looks pretty cool. But what happens in real life is that, you know, the light would hit the floor, it would bounce off the floor, and then you get some uplighting coming back onto the plinth here. Okay, now something we could try doing is actually adding bounce light to the scene using the light tracing feature in Max, which is Max's system for producing global illumination effects. So we'll go up to rendering, advanced lighting, light tracer, and turn that on. And if I set these parameters to be correct, let's just have one light bounce here. Let's actually make sure that's turned on in the normal renderer. Use advanced lighting, yes it is. So now if I do a render, what I'm actually going to do here is pull the window up here a little bit, pull that down and use the middle mouse button and use the wheel, and I can zoom in on our render here. And you can actually use the middle mouse button to pan around as well. So what I'm going to do now is just do a quick test render of that. And you should see that it's actually slower, but you'll see that you'll end up with slightly increased realism in the lighting. You'll see on the side of these little details here, you now have bounce light, and you've got the same thing on the plinth as well. So even though there aren't any lights shining directly onto the underside of the plinth, you can see the lights hitting the floor and bouncing off the floor and coming back up and lighting up the underside, which is a lot more realistic. It's much truer to real life lighting. So that's quite a nice effect there. The only problem we have with this at the moment is that if I turn on the particles, each surface in the scene will be tracing rays from their surface to the particles, and they'll pick up light from the particles, which is actually quite realistic again, but it'll actually slow down the render massively. So in this case, we're going to go for quite a quick render effect. So I'm not actually going to use the light tracer in the final effect. Oh, actually, what I may do is do a render with the light tracer off, and then do another render with the light tracer on. So that'll be quite interesting. So we can do a comparison at the end of this tutorial. So let's just zoom out there. So there we go. That's what the light tracer does. So for now we'll just turn that off again. So we'll go to rendering, advanced lighting, light tracer, and just turn that off. Now the final stage of our tutorial, we're just going to do a render of an animation of this, which will actually allow us to see how everything comes together in the end. So we'll go to the render dialog, into the common output, common parameters area, and up until now we've been rendering a single frame, so we're going to change that now. We're actually going to render an animation. So you can either choose to render a range. You can see here you can input a range, or you can just render the active segment, and the active segment basically is the area that you can see from here to here on your timeline. So you can just render this, and in our case it'll be exactly what we want. I'm not actually going to save out the files for a second. I'm just going to click render, and let's just see what happens here. Max will warn us, as you can see, you're rendering a sequence of no assigned file. In other words, you're going to render a sequence of frames, but you're not actually going to save them out. So it's just warning you here that you could actually be losing a lot of rendering time. So, do you want to continue? We'll just say yes. And Max will start rendering the frames, as you can see. And when it gets to the end of each frame, it'll just skip on to the next frame and carry on rendering until it's rendered the entire sequence that we've just told it to render. Over here in the render window, you can see you've got a completion status bar for each frame, and here you can see it's telling you that it's on frame 2, and that at the moment it's done 3 frames of 201 frames. So you can see all the other details here about exactly what the render is doing, what camera it's using, and various other details. Lights, is motion blur turned on, is anti-aliasing turned on, etc, etc, etc. You can see here it's also saying it's rendering 14 objects, and we've got a total of 15,900 polygons being rendered in the scene. So obviously if we wanted to sit through this would be quite boring. So what I'm going to do now is set this up, render it out to disk, and we'll come back later and we'll have a look at, as I said, both versions of the file. We'll render it once with the light tracer turned off, and we'll render it a second time with the light tracer turned on, and we'll see the visual difference between those two versions. Okay, let's just do that.